Hello everyone, I'm João from That's Brilliant. In this video we're going to talk a little bit about electricity. We're going to have a brief introduction to this topic. And there are going to be more videos about electricity on That's Brilliant. So please watch them for you to understand this topic completely. So as I said, let's have a quick introduction to the basics of electricity. And let's remember of what we study mainly in chemistry about the atom structure. And we study how an atom looks like, and the most accepted theory is this one. And I say accepted because this has been studied for many years, and all the time it's been studied and more things are discovered. So we don't know everything 100% about this topic, but this part we're going to talk about, it's almost certain that we understand correctly. So an atom has a nucleus, and we have two kinds of particles in this nucleus, and we're going to talk about the three more important particles of the atom, I would say. If you study this more deeply, we're going to say that there are a lot more particles, but the basic ones, the elementary ones that are enough for our study, are the three ones we're going to talk about. So basically in the nucleus we have two kinds of particles. The nucleus. We have protons and neutrons. And orbiting the nucleus we have the third particle that orbiting the nucleus we have electrons. So as I said, there are more particles, but for our purposes here, these three fundamental particles are enough, and we're going to consider that they are indivisible. For our study here, it's okay if we're going to see more particles if we study more deeply this. So, but it's basically these three particles, and we're going to study in electricity a characteristic called electric charge. So let me write it here, electric charge. This is what electricity mainly talks about. And this is a characteristic of protons and electrons. So first of all, let's see neutrons. As the name suggests, neutrons are neutrally charged. I want to say that neutrons don't have charge. They have a charge equal to 0. Neutrons aren't charged. And what's charged are protons and electrons. Okay, they are the two charged particles. And what's a charge? Well, it's, for example, mass. What's mass? Well, mass is an intrinsic characteristic of the particles. Things have mass. It's an intrinsic, an inherent characteristic of the particles. And so is the charge for protons and electrons. So the charge for these two particles is something intrinsic to them. They have it from the nature. It's on them. They are like that. We don't have an explanation better than this. It's like from nature. As things have mass because they do, it's their nature. For protons and electrons, they have charge. It's an intrinsic characteristic for them. They are like that in the nature. And what's this charge? Well, we notice that there are two kinds of two types of charge. Two types of charge. And we have to understand the difference between these two types of charges. So let's say I'm going to represent one type of blue and one type of green. So if it was observed in experiments that if we put different charges, they attract each other. They are attracted. One charge attracts each other. Different charges. But if we put the same type of charge together, or of one type or the other type, but they are equal to each other. For example, if we put blue with blue, oh sorry, I made the wrong arrow. Blue with blue, or green with green, they have repulsion between them. So as I said, we have two types of charges. We are here representing with green and with blue. We have two types. Different types attract each other, but the same type of charge, they repulse each other. So blue with blue or green with green, they have repulsion between them. And we have to give a name to each type of charge. We need to give a name. So we could call it green or blue. We don't do it, but we just have to give a name. What we have to understand that for nature, there is no name. The nature is the way it is. So we have two types of charge. Different types attract, equal types repulse, and this is how nature is. And we human beings want to give name. So this name don't affect the behaviors of the nature, but we have to give a name. So we could call it, for example, delicious and bad tasting. You can call it beautiful or ugly. You can call Batman and Robin. I'm not saying that these two are opposite, but I mean, you have to give a name, and it doesn't matter the name. You have just to give a name. So it was agreed to call positive and negative. For example, if you have a compass, you have the North Pole and the South Pole, but it's just a name. The nature doesn't know we give name, that we give name to things. The nature is what it is. We want to give names, so we decided to call positive and negative. One type is going to be the positive one, and one type is going to be the negative one. And we decided it was just a decision because the humans wanted. We are going to call the positive one the charge of the protons, and we're going to call the negative the charge of electrons. It's just a decision we made. We want to give a name, but as I said, this doesn't affect what the things are. So you don't have to say, we call the protons of positive, so they are good people, and we call electrons of negative, so electrons are mean to people. No, it's just a name. If we wanted to call the protons of negative, it was okay, but it isn't what we did. We decided we're going to call the charge of protons of positive and the charge of electrons of negative. So please understand this. The name, it's just a name. Okay, we just had to give a name, and we gave this name. Okay. So another thing we have to understand, we have a value for the charge. So we measure the charges. We have a unit for it, and we're going to see more about this unit later. But we use Coulomb as unit of charge, electric charge. Okay, and we use to represent Coulomb, we use just an uppercase letter C. And we have the fundamental charge. We are going to call it of E. The fundamental charge is equal to 1.6 times 10 to the power of minus 19 Coulomb. This is the fundamental charge. So this value is given by experiments, is on the laboratories in experiments that we see this value. So the elemental charge is 1.6 times 10 to the power of minus 19, and this is the charge of a proton and the charge of an electron. So we see experimentally too that the charge of a proton is the exactly same charge of an electron. there are only a difference. They are oppositive. They have opposite behavior. One we call positive, one we call negative. As we saw, different types of charge attract, equal types of charge repulse. And for the electrons and protons, the value of the charge is the same. The difference is that one is positive and one is negative. They are oppositive, but the value, the magnitude, we can say, just for understanding, is the same. So we say that a charge of a proton is plus E, is positive E, plus, not plus, sorry, it's positive E. And the charge of electrons is minus E, is negative E. So the charge of proton is positive 1.6 multiplied by 10 to the power of minus 90. The charge of an electron, of one electron, is negative 1.6 times 10 to the power of minus 19. So, as I said, I would say the size, just for the understand, the size of the charge of protons and electrons is the same. The only difference that is one is positive, the other one is negative. They have oppositive behaviors. But if you have one proton, it's going to be exact the charge of 1.6 times 10 to the power of minus 19 coulomb. The charge of an electron is negative 1.6 times 10 to the power of minus 19 coulomb. So this is the basic introduction we are going to have in this video. So as I said, please watch the other ones for you to understand everything completely. Thanks very much for watching, and I'll see you in the next videos.